Today we're going to show you a Model 5300 EtherCAT master and how it can be connected up to various EtherCAT devices on an EtherCAT network. Here we have a 5300 with an M341A module plugged into it, and also a 16 input, 16 output module. The first thing we're going to do is to connect the EtherCAT wire to the M341A EtherCAT master module. From there, we take the other end and go to the input port of the back-off I/O block. From the output of the back-off I/O block, we're going to connect in the next EtherCAT cable that is going to the input port of the Yaskawa Sigma drive, servo drive. We'll then connect up the servo motor encoder, the servo motor power cables, the inhibit and forward and reverse limit switches for the drive, and then lastly the AC input. So once we have the network completely configured, we will power up the 5300 with a preloaded program to run this servo motor. Now, as it's going through its boot up sequence, the master module is going to go out and query the network looking for the known and supported devices. Once it does that, it will build the resource map just as if the controller was a rack and you were plugging boards into a rack of a CTC controller. So those of you who are familiar with the CTC control platform, it'll be virtually the same. So once fully booted, the servo axis will run a simple routine, and then we can go in and take a look at the program itself and see how it was developed. To view the EtherCAT master's configuration and what's on the network, you can right-click on the CPU and select EtherCAT Explorer. From here, you'll see the EtherCAT module plugged into the controller, and then beneath that, you'll see what was found in the network in the discovery process. The first node, slave number 1, we show the back-off remote I/O block with analog and digital I/O slices built into it, each assigned as a slave number. And then we see the Yaskawa Sigma 5 rotary axis as the 10th slave, but the first axis in the system. Over on this side here, you get a view of what's happened, a snapshot of what's going on with this particular drive, and some important information about the axis and what's in the drive, whether it's running, what mode it's currently in, and what the current position was at the time of the snapshot. Then what you can do, go a little bit further for diagnostics and get a view of the log buffers. And what that does is it tells you what currently happened in the discovery process and how they were brought onto the network. Verified with the license, and then we get safe op begin, and now we're running. If an error were to occur, it would show up here, and we'd be able to trap that and be able to get a better definition of the type of the problem and where it is. The next thing we're going to do is go over and look at the program itself. I have a motion sequence block that's been set up with a small set of commands. In this example, we're going to move a servo motor from one position to another position and then back again. We first start off with giving the motor a defined speed, and in this case we've set the resolution to be 15 revs per second. We then do a motion where we're going to say move at speed to a predefined distance using XL and decel parameters at the end of the instruction. And then we're going to wait for the servo axis to get into the final position, the target position. At this point, we're going to delay 1 second. Move to the next part where we're going to set a new speed to 20 revolutions per second and move the axis at that speed back to the starting position using the same XL and decel parameters as the previous move. We then wait for the axis to get into position, delay 1 second, and then go back to the destination label called cycle move out. And this program, in a simple form, just runs forever back and forth.
For more information or to discuss the technical requirements of your own installation, you can contact CTC application specialists at 800-282-5008. Thanks for watching.